Good morning one more time. My name is Błażej Siudaj and I'm product manager for Servo and Motion Group. And together with me is Jacek Taczała, product manager for robots.
Hello, everyone. One more time.
So I think we can start. And before we go further to our presentation, I would like to tell a few administrative things. First of all, on the top of the screen, you can see the bar with the button for registration for free of charge consultation with us. And we would like to invite you to click and register yourself if you would like to talk about the possibilities to extending our robots functionality with servo, of course. We would like to invite you for that kind of activity.
And what is important, if you will be having any question, please just type it on the chat. And please remember to add the mark question.
Yes.
Because after the webinar, there will be Q&A session that we are waiting for it.
Yes, and Click Meeting platform is working like that. When you put the question mark on the end, your question will be visible in Q&A mode. So please remember about that. But of course, we will look also directly to the chat. Okay, so let's start today's meeting. And on the beginning, I would like to also mention about previous webinars. And if you'd like to see what we already presented before, you can find all of them on our YouTube channel. And we were talking about energy efficiency, predictive maintenance, accelerating of machines, and more about the servos. And that part was the initial part for today. And today, we would like to talk about another topic. And what is quite interesting, how we can use 1 meter robot handle a 2 meter pallet. You probably have 2 questions in your mind at this point.
But Błażej, the question is, why does this webinar start with someone who is responsible for the servo, and the title we are talking about is about the robot?
Yes, this is quite interesting. And second question, how can such a small robot handle a 2 meter pallet?
Yes, so firstly, the reason we say in that many application, thanks to the synergy of the product, we are able to do something more when we connect one of our product with the other one. And today we will be talking about the connection between the robot and the servo. So therefore, with the help of 2 match puzzle, we are able to significantly increase the capabilities of our solution.
Yes, and in this case, those perfectly fitting puzzle pieces are our robots and servos.
Exactly.
And in general, this is a preview of next webinar series in which we will talk more about the synergies between different products of our company. But going to the topic of our webinar, Jacek, how to stack 2 meter pallet with 1 meter robot. It is even possible?
Yes, it is possible, but firstly, let's define what does it mean small robot. So when we are talking about the small robot, we are thinking about the robot that will be having the payload up to 20 kilogram, arm reach up to 150, something like that, and it is required to have in the standard the palletization function included in the robot to have application to have a possibility to realize the application with low cost. Yes, regardless the size of the pallet, it is possible to perform palletizing using small robots. Remember that in the lifting capacity of the robot, we must include the weight of the gripper. In addition, using such a robot, we reduce the production space, which the price today is very, very high. Because naturally, the small robot takes up less space. This is especially important when we have relatively small area, as I mentioned, on the production side. On the other hand, there is a topic related to the limitation of the height, which we can realized by the small robot. Therefore, if we would like to realize 2-meter pallet, of course we can use big robots. Finally, in our offer, Mitsubishi Electric offer, we are happy that we have got such a big robot, because with our big robots we can even realize 2 and 2-meter high pallet, so it is possible. But today we will be talking about the possibility of realize the palletization of some product with a small robot that require additional movement. And here we come to the crux of the webinar.
So, servo connection to the robot.
Yes, exactly. We will look into this topic more closely. But Błażej, very important question. From when we can connect the servo and the robot?
Very good question, Jacek. And in our portfolio, this functionality has been with us for a very, very long time. Because in fact, since from J2 series, that is, we have that functionality for more than 25 years, which means that we have a lot of experience in that type of application, which I hope we will show on the end. On the other hand, I have a question to you, Jacek. The question is, how can we connect the servo with the robot?
Yes, this is a very good question. Of course, we have got different solutions in the aspect of the control. So firstly, let me introduce you the possibility of putting our robot controller on the IQR platform. And in the robot controller, we have got, each of the controller is equipped with the CCNet connector. It's in the front of the controller. And we can connect by CCNet cable using the CCNet connector up to 2 interpolated axes and up to 6 point-to-point axes. So we have got directly included in our controller this kind of the possibility. So interpolated and point-to-point. And here I think it's a very good question to you, Błażej, as a person who is responsible for the servos. What servo drives? What are the differences between point-to-point control and interpolated control of the application with servo?
It is a very good question, Jacek. So let me explain. So let's start with simple issue, namely point-to-point. So on the left side of the slide, you can see animation. Such drive control is based on the sending a command with movement parameters and start command. And when the axis will start working, we are waiting for the movement to finish. Of course, in the middle time, receiving feedback of the process, feedback about the position, etc. In case of an interpolated axis, we send a new motion command with new parameters every communication cycle, every single communication cycle. So we can fully control the motion of the drive and follow very complex motion paths. So in this case, we are able to control fully motion and what is more, master generating the path, and this master can be robot. And we don't need any typical motion controller. Therefore, going back to our drawing, 2 of the axes are interpolated. One can act as 2 additional axes of the robot, fully synchronized with it and performing advanced movements together with 1 typical robot, 6 or 4 axes. And the other 6 axes can be as a setup axis that won't be synchronized with the robot. But Jacek, how it is programmed?
Błażej, thank you for explanation. What are the differences between interpolated control and the point-to-point control? Because when we would like to connect the servos to the robot controller, we can connect 3 mechanisms. The first one, we can add 2 axes, and this axis will be interpolated. So we have got whole mechanism with the robot that can our robot controller can interpolate 8 axes, and we can additionally add two additional mechanisms when we can add additional 3 axes. So this is such a robot can control even external manipulators or axes. This means a reduction. This possibility means a reduction of the costs, because, for example, if you will be having the whole line and at the end of the line you don't need the robot, only the manipulator, you can use robot controller to build such a manipulator.
That is, as I understand it, we have a lot of space for cost optimization of the master controller. But here also I see an extremely important thing, namely such a robot control axis operating in the collision space will be easier to control because we don't have any delay in data transmission about position, etc., between the robot and master PLC. And the PLC control drives, as well as we simplify the writing of the control because everything is inside of the robot.
Yes, exactly. And you can see on this screen the view from our RT Toolbox software where we are able to put additional axes, put the robot, and we can check everything in the layout in our solution. So everything can be checked in the simulation mode that is in our standard. But what is more, you can even have the possibility to have the visualization of the program of controlling additional axes in our teaching box. But that's not all. You can also have the possibility of the visual of your 3D model in this teaching box. But the most important is the program for the robot programmer. Yes, this is that is in one word. Once we have prepared the configuration of the servo connection to the robot, we program the movement of the external servo axles themselves as easily as we program the robot itself. Therefore, the work for the programmer may be extremely easy if we have additional axes in our machine, in our simulation, in our production plant. Yes, and here is really nice example of the small robot that is on the additional axis. The robot is making that palletization. And what can you see here? On the left side, you can see the whole of the program that is being realized. In the middle of the screen, you can see the visualization of your robot. Please remember that today, this kind of the visualization you can also see in the teaching box, this one that we were showing to you. And on the right side, that is everything that robot programmer needs. So position of the robot, position of the manipulator, so every coordinates can be seen by the robot programmer. Yes, as you could see in this simulation on this slide, what is very important, when we use interpolated axis, the robot recalculates the kinematics by itself, and we don't have to play with any additional calculation. So it means less time for you and easy for you. The controller will guide the robot to execute the given command as efficiently as possible, taking into account the position of other axes. It means easy. Yes, and here is very beautiful example. The robot can control additional axes. Here is some example of the welding robot that control themselves, control additional axes, and making the interpolation of the movement.
Yeah, looks very impressive, Jacek. But does this function only work with our company's PLC, or along with other PLC, can you also use those additional axes for the robot?
It is very good question. It is very good question. What we have to say, Mitsubishi Electric is not conservative. We are extremely open for connection with different solutions. Of course, very important is to add that if you are realizing the machine with whole our package, it may be something easy for you. But of course, if you have got some standards, we are able to connect the robot with any additional networks, industrial networks that we have got on the market. It can be Ethercat, Profinet, Ethernet, IP, so we can use different PLC.
Very nice information for all of you who, from some reason, cannot use our PLC, but maybe you would like to use our additional functionality for robot. And the question from my side also is, do we have still all presented functionality, even with the communication?
Yes, if we use any external PLC, all of these functionalities that we are showing you will be possible to realize it. But okay, now Błażej, the question for you. Where do you think we can use this functionality? Nevertheless, it will be our PLC or external PLC.
This is a good question. I think we can use this functionality especially for linear movements. That is, we can move our robot with tooth belt, with rack and pinion or screw. I mean, we can build our own mechanics. And of course, rack and pinion or bar screw will give us better precision, and tooth belt will give us a lower cost. But from the other hand, if we don't want to build, to construct our own solution, we can use ready to buy from the market commercial solutions. Of course, if the strength of such modules allows us to do that. Such modules on screw on the market are usually up to 3 meters and with tooth belt up to 10 meters. In addition, there is a noticeable trend away from pneumatics and replacing it with drives with screw, belt, rack and pinion, or screw connected with servo. One of the possible systems is also a piston rod actuator, like you can see it on the right-hand side, which from construction point of view looks very similar to pneumatic cylinders, and we can change pneumatic cylinder like one by one substitution by that kind of solution. Going further, we can build the grippers with servo in particular. As the requirement for robots are becoming more and more complex, and it is necessary to use systems like that, allow our machines to change formats, rearming grippers, etc. Are these good ideas for servo using with robot, Jacek?
Błażej, these ideas are very, very good. But before showing you some examples of practical use of this functionality, I would like to show you and our viewer of this webinar what we can generally do with our robots. So please remember that we have got the possibility to realize all-in-one. What does it mean? With Mitsubishi robots, we have got all of these functions that you see as a standard. You don't have to buy it in the future. So you will be having all of these functions. These functions are like collision avoidance when you use our PLC, collision detection with different PLCs, different external controller. You can do linear tracking, circular tracking. You can connect our robots to the 2-division system, to the 3-division system from different supplier. You can realize compliance control. And what is really, really important, you have got also this feature that we are discussing today. So additional axis control as a standard with every of our robots.
Good news.
Yes, and it's really worth to add that all of this function you will be having in our 6-axis robot portfolio. So for the robot from 2 kilogram to 80 kilogram. So it means that you can diverse application offering high precision, flexibility, and reliability using all of this function that is included. So you have got it in this robot. Additionally, in the portfolio of SCARA, you can also have this possibility. Our portfolio, so these are the robots from 2 to 20 kilogram. This high-speed 4-axis robot excel in tasks requiring precision, speed, We can use it in the assembly, packaging, handling. So these are the robots that we can offer. But let's discover how we can optimize your production using additional axes. Yes, so please remember that our proposal with additional axes can be further strengthened with the integration of our cooperation with external sub-supplier of the external axes. So one of them is Gidel. So as you see, you can make any mechanics as you wish. You can build such a big manipulators, and we can, with Gidel, we can offer you different construction. We are able to offer you any linear axis as you wish, even with the payload up to 3 tons. But what is important, me and Błażej will be responsible for everything, for right calculation, for right robot, and for the right servos. So that's why we would like to extremely ask you to attend to a discussion with us, to make some consultation, because we can help you with this kind of the solution. Today we are also discussing about the smaller robot. And Gidel has prepared some really nice solution. The name is Kobo Mover. Don't be misled by the name. It's not just the solution for the cobot, but you can use also for robot. Really light additional axis that we can use for our robots up to 8 kilograms. This is a comprehensive solution, as it comes with a base plate for the specified robot, so it will be plug and play. You just need to tell us what are the dimensions, and with the servo, it will be HGSR102 or 1024. With the cable, we can connect the controller to the servo, offering a complete package. It's a cost-effective solution, really nice. So we can add our robots to this kind of the solution and create some complex package. Yes. So partnership is very important. Although we have got the ecosystem, we are open for partnership. That's why with the connection of our servo drives, Gidel construction, our robot, we can realize some kind of the vertical track that you can see. And thanks to this solution, we can build 2-meter high pallet with small robots. I would like to mention one more time that we are responsible for everything. Choosing the vertical, the right drive, the right gearbox. In addition, we will support you with the commissioning. And the question, Błażej, to you. What do you do, Błażej, even have in this servo?
Good question, because we are talking a lot about robot portfolio. So let me show you our servo portfolio. In servo, we are talking about 2 product lines. We have quite long history in servo technology and many series released. Historically, the older series is the most advanced series, and the second line is the economic line. The current supported series are J4, J5 from the most advanced line, and GE, GET from the cost-effective version. Going further, the power-wise, latest J5 is from 50 watt to 7 kilowatt currently. In short time, it will be 25 kilowatt. J4 from 10 watt to 55 kilowatt, and the economic line from 100 watt to 3 kilowatt. What is important here, currently SSCnet version is supported by J4 and GE series, so those lines we can connect directly to the motor. But like you can see, the power range available is very big. And one comment also about the latest series, J5 version with SSCnet will be available also soon. And about the motors, we can support with the motors from the smallest ones with flange 25, with power range from 10 to 30 watt. Another small motor flange is 40 millimeters square. Such motors came from power like 50 watt, even to 150. These motors are ideal for robot grippers, for example, where the weight of the components is crucial and high power in very small package, in very small mass is a plus. But from the other hand, the biggest possible motor in our portfolio is 220 kilowatt. These are large motors with very powerful parameters, and we are unlikely to use them with robot. Why they can be controlled? While they will be controlled by the robot itself. And what's more, our amplifiers can work with other types of motors. It is not only servo-synchronous rotary. We can mount our robot also on track with linear servo, or also we can cooperate with direct drive servo, and that kind of solution can give us very high precision, big dynamic, and significant loads. So now, when we know what Mitsubishi have in servo offer, I would like to ask finally our question. Yes. How to stack 2-meter pallet with 1-meter robot?
Yes, I think that basing on what we present before, we have got the solution. So we have to use the linear track that is using additional axis with a servo controlled from the robot controller. We raise the robot to the higher stacked layer of the pallet, and we can reach the next item by going down for the robot to take the product, to take the boxes.
It looks very impressive, and I think that now we have almost unlimited pallet height. But do we have another examples?
Yes, I would like to show you some of the example realized by our partner, because and what is important, in this example, we use additional free servos with the robot.
What do you mean free?
Yes, in this material, we present representative of the FR series robots, so 6-axis robots with the payload up to 20 kilogram and the reach arm up to 1 meter, so small robot. This robot was tasked with performing a can palletizing process, as you see now on the movie. The requirements limited the robot's working space, and it was very, very tight. So a compact robot was necessary. The ability of this robot to control an additional axis, along with the integration of that axis, meet the machine space constraints and allow the task to be successfully completed. So with small robot, we were able to realize the application. So here you can see axis number 7 and axis number 8. Axis 7 is realizing the lifting, and the axis 8 is realizing the shift.
And what about the third one?
The third in this presentation, and you can see on the photo, you can see the additional axis. Additional axis number 3, as you asked me, is mounted on the gripper, and this axis enable movement in the this axis enable to put the product in different position, put the gripper in different position, so we can additionally have the possibility to change the construction of our gripper thanks to the additional axis that is on the gripper and realizing point-to-point control. Yes, the movement of the gripper fork is controlled by the servo and adjusts its position, as I mentioned. The robot itself controls this position. As you can see, the robot is opening and close the gripper, realized by the servo. In this application, of course, we use the small servo, as you were presented, Błażej, so the gripper is not so heavy. And this makes it easy to modify thanks to the servo is controlled by the robot controller. We can in easy way make the modification of the program, even if we are realizing remotely, because we can remotely have the access to RT Toolbox and make some changes.
Looks very impressive, Jacek. And actually, do we have any other interesting examples?
Yes, I prepared for today's webinar also really nice example. Here will be only photo, but I will present you what we can see here. This application was realized by International Tobacco Machinery Company, so company which is the these are the experts for the tobacco company. In this application, in this setup, the robot is mounted on the guided track and operates as a bobbin changer. The robot task is to pick up the bobbins and place them into the machine that you can see on this picture. So here we have got the installed guided TMF track, so very big one, and the robot RV13 FRLM, the robot which has got 13 kilogram payload and circa about 1.4 meter arm reach. So robot is mounted on the sailing and moving on this machine.
Impressive.
Yes, and other example, as you see, comes from our digital twin simulator Gemini. But this application really exists. Here we have got 3 robots on the linear track, operate 60 CNC machine per robot. So as I mentioned, this is real world scenario that was simulated in the Gemini environment. Here we can show the details, how the robot will be working, how the robot will be working on the additional axis, what will be the cycle of whole the production process. So thanks to this, that we can measure everything, we decided to use 3 robots, and we have got such a multiple robot and multiple CNC production process. That is shown in the Gemini. Yes, and here we have got some real example from Japan. The previous one was from Central and Eastern Europe, but this one is from Japan. I would like to also show you how the Japan is making the machine with our robots. So here we have got the robot RV7FR, so 7 kilogram payload with additional axis. The space also was very, very limited, as you see. And the track extends the robot's working range, eliminated the need of using larger robots which consume more energy. Please remember about it, that if you will make the reduction of the robots, you will make the reduction of your invoice for the energy. So the linear track make the workstation more compact and the ease of the programming, because the robot is directly the controller of the servo is directly controlled to the robot. And here we have got really precise assemble process thanks to really precise servo, precise mechanics.
As you can see, as an example, the combination of servo and robots are often found in different configurations, from palletizing to mounting applications. And they work together very strongly, like you can see. So I think when we consider a robot for our machine, maybe servo with that. So maybe you can extend functionality of your robot very easily with our additional axis functionality.
Because this functionality is
always in standard. You need to buy only the additional amplifier, motors, and all accessories. You don't need to pay any additional money for licensing, etc. And
what about the question? Please remember that if you have got any question, please put it to the chat, because the session Q&A is really interesting always. Yeah. Because you can ask us for everything. This will be time for you.
And also, I would like to remind you about the button of the top of the screen, and you can register yourself for consultation with us about the robot and servo functionality and extending of its functionality in case of your applications. And before we go further to the questions, we would like to invite you also for other webinar, next webinar, which will be the next part about the combining robots with other solutions, for example, servo also. And this webinar will be presented by Jacek and one of our colleagues from technical department, Patrick, and they will show the digital twin. So maybe Jacek, you can invite our audience for next webinar now.
Yes, the next webinar, that will be 24th of November, we will be showing you how to design an optimal robotic application using digital twin software for simulation process. But we will be not showing you that this system is only for simulation, because simulation you can do in RT Toolbox or even with Blender, that is free of charge software. We will show you something more, how digital twin can support you with building the machine, how you can connect with we can connect the final user and the machine builder, how we can connect the constructor with the PLC and robotics programmer, and how can we optimize our machine, realizing the cost savings, because we will show you how to reduce the number of the robots, how to reduce, thanks to this, the energy. So it will be something more than only digital twin, and it will be in 1 month, because today we have got 19th of September. So please join. On the meeting there will be also Patrick. Patrick is my colleague from technical department. He is the person who is making the commissioning of our robots, but also he made some visualization of the process for our customer in Gemini. So there will be a lot of practice. So please join even today. You can make the registration.
Yes, so that will be very useful for impress your customers when you will be able to prepare that kind of simulation. Okay, so now I think we can skip to questions.
Yes. Please remember that during the answering, you can also put the question to the chat.
Okay. Okay, let's go to the question Q&A mode. So the first question, you have shown palletization with robot with additional linear axis. What are the pluses of this solution instead of using palletization robot? For which application it can be used?
Yes, so this application can be used, of course, for the products that the weight will be lower than 20 kilograms. And for the production that the space is limited. So these are the pluses of using robot with additional servo. Why? Because you will be not consuming such a big place. You will be using less energy. And thanks to this solution is as a standard with our robot. You will not put additional money to build such an application. Another pluses of it is, for example, future maintenance. The maintenance of smaller robot is smaller than big one. So you are reducing the cost of the future maintenance. So, and what is more, if you have got the production, when you are also using small robot, if you will use small robot for palletization, it means less spare parts on the your warehouse. So of course, there are a lot of pluses, but please remember that this is for the smaller product. Of course, if the product is big, the boxes are big, it may be difficult to use the robot which has got the payload 20 kilograms.
And I would like to add one thing. We met a lot of problems about the space in customers' factories. That means currently they have space like one pallet and something around, not as much space as it is necessary for very huge palletizing robots, where you need not square meters, you need hectares of space. So it is very effective solution for places where we don't have much space on the floor of the factory. Okay. The second question, of course, in the middle time, I would like to invite you to asking questions, because it is very important to answer for all your questions. Second question, also from Adrian, if I order the manipulator with your servos controlled by the robot, is it whole solution, or do I need some extra mechanics and you are providing only linear modules? So maybe I will answer for that question, depending, of course, of your needs, because we can support you with ready-to-use manipulator, Cartesian system, or if you prefer to build it by yourself but ready-to-use modules, we can also deliver whole set but like Lego bricks to your own mounting. So depending of your needs, we are able also to support you with ready-to-use Cartesian systems, even like shown before Gidel 3D very big Cartesian system. Okay, we have other question from a bot maker.
Please
translate it.
We would like to kindly ask our colleague Alexandra, who is with us, if she could translate it to English or better to Polish.
Because thank you for this question, but it will be easier for us if you will be able to write it in English. Okay, in the middle time, I will check the chat because maybe we have some other questions there. Okay, thank you, botmaker. This is from Slovakia. Thank you. Okay, I see one more question, but currently on chat, not in Q&A mode, so I will read it. How about the safety? If I need to restrict the area of, for example, now it's working in a QA mode. If I need to restrict the area, for example, with light curtains, how the additional axis will behave? Can it also be safety stopped or slowed down? One of examples you shown had the light curtains. Answer is quite simple. All drives, what we can connect to the robot, can be equipped with advanced safety, but it's equipped with standard safety, also only STO stop in standard on board. If you would like to build application with advanced safety like SLS or other more advanced version of the safety stop, we can use Series J4 with advanced safety, so it is also possible. Okay, I see other question. Maybe it will be better for you, Jacek, to answer.
Do you have a specific webinar? How should I integrate a plus additional axis in GXWorks 3? Of course, we can generate this kind of the webinar, but when we are talking about the robots, it's much more easier to use the functionality that is built into the robot controller. So better for you is to control the additional axis directly from the robot, because, for example, if you will put the robot with 2 kilograms, with the arm like my hand, and put the function move to here, somewhere there, so the robot just move there using additional axis. When you will be realizing in the GXWorks 3, of course it is possible, but you will be needed to create the connection between the robot and the PLC. Of course, it is also easy to realize it. You also using external PLC, but better and faster for you will be to use the function that is naturally included with the robot controller.
Let's repeat it. We have functionality in standard in our robot controllers to connect two interpolated axes, to move the robot together with its kinematic interpolate, and 6 point-to-point axis. And we don't need to turn on any GXWorks for that amount of axes. If we would like to build application with hundreds of axes, we can of course add our motion or simple motion module and synchronize motion module with robot controller. But that solution don't give us possibility to program those axes inside of the robot controller. Okay, we have other question. Do we have official partner in Bulgaria? Yes, we have. So please,
very good one.
Yes, very good one.
Very good two.
Yes, 2 ones. So please click the registration button on the top of the screen. We will share with you the contacts to our partners. It will be the best way to get it.
I think that it's worth to add that our partner in Bulgaria are really experienced in the robots and the servo. So we have got really nice partners.
Yes, exactly. Okay, and just a second, because the Q&A mode is skipping from one question to another.
It's okay.
Okay. Next question from Adrian. When having connected servo as point-to-point access to the robot, it is still possible to manually control it or program via robot hand programmer, or some external software is needed? Also, is there some limitation of the servo capacity or not? I will start from the end. Limitation in servo capacity, 220 kilowatt motor. I think you don't need as powerful motor as I mentioned, but it starts from 50 watt. But for you, other part of the question, is it possible to control manually? Yes, it is.
Yes, it is possible. From teach band, you can control the additional axis, as we were showing during this part, when you can see L1 and L2. So L1, with the example of the robot moving up and down, it was the position of the robot on the linear axis. So you can in easy way control manually by joke mode the robot on the linear axis. It will be very important for you because it will help you to make the application.
And I would like to add that it is easier to control servo by pitch pendant panel than from HMI or something like that.
Yes, and this is also, we can back to the question about putting the additional axis for the robot in GXWorks 3.
Yeah.
Because it will be limitation, because you will be not having the possibility to control by teaching box.
Yes. Okay, other question. Is it possible to use this function with selling mounted robots? If so, what are the load capacity?
Yes, so all of our robots from RV2 to RV12 can be mounted on the sailing. One of the limitations that we have is for one of the version of RV2FR robot, because the robot has got only the brake on 3 axes. The other one has got the brakes on all of the axes, so there will be no limitation, and you can put the load that is nominal dedicated to the robots. So thank you very much for the question. We really like the application when we need to put the robot on the sailing, because the mass is not so big, the robot is compact, and the payload is quite high for the mass that our robot has got.
Yes, and we have next very nice question. What will be the achievable repeatability of the system composed of robot and additional axes? Of course, first of all, it depends on the robot, but our robots are very precise. But the second part of this question is connected to mechanics, because if you will choose tooth belt, the tooth belt will destroy, let's say, repetition repeatability of the system, because tooth belt typically have more or less plus minus 0.1 millimeter of repetition repeatability. But if you will choose screw, or if you will choose the rack and pinion solution, or even if you will add external encoders, you can reach very nice repetition accuracy, much below a repetition accuracy of the robot. So finally, total set can work with repetition accuracy of the robot. What is actually 0.02?
As I remember, Kobo Mover that we are presenting has got plus minus 0.02 millimeter. So it's really.
But you can remind our audience, what about the robots?
The robots, RV2 has got, for example, 0.02. RV13 has got 0.04 millimeters.
Impressive. So we can reach that precision in our application, even if we will add additional axes.